So this is the first one. Now, some of you may have been to some of the Max Maths webinars that I ran for the Caribbean a couple of years ago. Yeah, it's back for me as well, Jeremiah. You'll have noticed that I actually find it really useful. People being in the chat, it makes it feel a bit more real for me. It makes me feel as though I'm talking to real people. One of the odd things about webinars is that you can just feel like you're talking to a computer screen rather than a group full of people. But what's lovely about Trivia saying to me, "All good now," is that I now feel as though I'm in the room with Trivia and Sinead. The other thing I need to say right at the beginning is my apologies for if I get your names wrong. I think it's better to try and get them wrong than not try at all, but feel free to go in the chat and correctly. Monek, I'm going to say for Monek's name. So what's the point? What's the purpose in updating Explore Maths and thinking about how you can write a useful textbook? And I kind of want to go back to lockdown, because one of the things that I was doing in lockdown was a lot of webinars for people like you, for teachers around the world. And that was fascinating because it felt like it was a way of bringing everybody together from all around the world. A bit like we're now in a room with lots of you from all around the Caribbean working together on thinking about mathematics teaching on a shared endeavor. It was the same during lockdown, and we've kind of got used to that way of working. Hopefully, for those of you that are still not able to get back in school because of the hurricane, your experience of working in lockdown has allowed you to go back to that way of working, the ways that you were working with the parents, the ways that you were working with the children, to carry on supporting their education, even when the kids can't be in school. I've actually got 5 grandsons. I have no granddaughters, I have 5 grandsons. And the eldest is now 11, and he's just about to go on to secondary school, to high school. So he was 7 at the beginning of lockdown. And his teacher from primary school contacted me, and she said, "Can you help Felix with his maths in lockdown?" And I said, "Yeah, of course I can, that'd be nice. What do you want me to do with him?" And she said, "I just want you to make him more confident," which I thought was interesting. And I also thought, what a great curriculum. What a great mathematics curriculum. If that was the only statement in the curriculum, hi Kadia, make children confident in mathematics, wouldn't that be interesting? And wouldn't it make us have to think really hard about how we taught and what we taught? And I think that slightly changed the way that I thought about writing textbooks. Now, we haven't got the luxury of just making up our own content, but we can think about what it might mean to make people more confident. So obviously Explore Maths is written around the content of the Jamaican National Standards curriculum. I've also written the primary textbooks for Belize. That's my other big project with Macmillan, and we've worked around their new curriculum. And I remember after working with Felix, and I ended up working with all of his mates in school. So I was having an hour Zoom lesson every day with 18 kids, which was Felix's classes, in a lovely small class. And they eventually got back to school. And my favorite part of the week, I look after 3 of my grandsons on a Tuesday, 1 day a week. And my favorite part of the week is walking them to school and the conversations that you have when you walk them to school. And there was one walk to school when I think Felix was probably about 9. Hi, Mark. And he was doing his table tests in the morning, and he was doing his 12 times table. And he had become more confident because of the way that we'd worked over lockdown. But he wasn't confident with his 12 times table. And the conversation went something like this with him. I said, "Well, do you know your 10 times table?" And he said, "Of course I do, Grandad." And I said, "And do you know your 2 times table?" And he said, "Of course I do, Grandad." And I said, well, you know, your 12 times table then. And he looked a little bit confused. And I said, well, if you can do your 10 times table and you can do your 2 times table, you just add those two together and that gives the answer. And he said, well, what do you mean? And I said, well, do you know 6 12s? No, I don't know 6 12s. And he was a bit flustered. He wasn't confident about that answer. I said, well, what's 6 10s? 60. And what's 6 2s? 12. And what's 60 and 12? 72. So 6 12s is 72. And I don't think he was entirely convinced, but he could seem sort of thinking about it. And I did a few more of those examples. And then we just counted in 12s, and he was used to counting in 12s because that was the sort of thing he did in school. So we were in 12, 24, 36, 48, 60, 72, 84, and so on. And we did that a few times. And I said, what do you notice about what's happening? And he said, well, what do you mean, what do I notice? So I counted for him while he was noticing. And I said 12, 24, 36, 48, 60, 72. And he stopped me and he said, oh, well, the 10s are just going up in ones. So it's like 10, 20, 30, 40, 50, 60. But then it's the even numbers at the end. So he was noticing a pattern. And that convinced him a bit more that the 10s and the 2s. It's great, Sinead, because actually you can do any multiplication. You can do 17s if you know your 10s and your 7s. You can do your 14s if you know your 10s and your 4s. So it's just a way of kids becoming confident with those sorts of numbers. And then we did the kind of tables tests. The 1 times 12 is, 2 times 12 is. So by then he had 3 different ways of working on his 12 times table. And he came back home that day and he'd got 10 out of 10 for his test. Why do we always ask 10 questions on a times tables test? I don't know, but he got 10 out of 10 anyway. And was more confident. Now, at age 11 in the UK, all the 11-year-olds do what are called standard attainment tests, the SATs. And on one of them, he got 100%, and he was absolutely made up. Morning, Jennifer. Looks like a very good morning, all in capitals. Welcome to the webinar. And he's moved from being somebody when he was probably 6 or 7 who would cry if he got stuck in mathematics to somebody who was delighted when he could come home and say, I don't believe I got 100% in my exam. And actually, he quite enjoyed doing the examinations because he could show people what he could do. And isn't that the stage we want people to get to? To get to the stage where they want to do exams, because that means they can show everybody what they can do in those exams. So that's kind of now how I try to write. I imagine I'm having a conversation with my grandchildren. Interestingly, a lot of the work that I was doing, a lot of the activities that I was doing with Felix over lockdown were things that came from the Explore Maths and also from the MyBZ Maths, from the books I've done for Belize. So what we're going to try and do in the webinar. Hi Chelsea. The webinar title is called Improving Results, and you'll notice that I've already talked about confidence rather than results. And I think mainly what I'm going to talk about is all the stuff that comes before the test, which does mean that children will do better in the test. And I think confidence is one of those things. If we're confident, we don't get that feeling in the tests that I can't do this. You will all know that feeling. I know that feeling sometimes in examinations where my mind just goes blank and I go in a panic. And then I can't be successful. I can't show people what I can do. So we're going to think a little bit about what we mean by success. Because if we only think about the exam results, what we tend to do is just give practice examination papers. Now, if you think about it, practice examination papers are very helpful if I can do them. They're not very helpful if I can't do them. So for the kids who are going to be successful anyway, they may be a little bit more successful because they get used to the questions. But for the kids who maybe struggle a bit, it won't give them more confidence seeing the things that they can't yet do. It's much better to work on their confidence so that when they then see that question, they feel as though they can do it. And one way to think about success and one way to think about how we improve results is by having a look at what happens around the world. The good thing about, like I say, about these webinars is that we can explore the ways that other countries work on teaching mathematics to improve results. It's an aim worldwide, globally, is to think about how can we improve our results in our country so that we move up the league tables. And I mean, league tables are interesting, aren't they? Because if everybody's doing exactly the same thing, presumably the league tables will stay the same. You can't kind of overtake people because they're doing what you're doing, and everybody's getting better at the same rate. So I wish countries maybe would think about their own kids, and are their own kids getting more confident, getting better at what they're doing, and more able to contribute to the life of the country, to the culture of the country, to the culture of their community, and are they more able to use mathematics to control their own lives as well as to make things better for other people around them. And then maybe the most important thing, hi Marie, is thinking about, okay, so what does this mean in the classroom? What does this conversation that we're going to have about success, what other countries do mean for me in the classroom the next time I go into the classroom? And so the third section of the webinar will use some activities from Explore Math. I think people in St. Lucia, people in St. Vincent and the Grenadines, Kamisha, I think you'll be able to use all of these things in your classroom. A bit like whoever it was who just enjoyed the 12 times table. There's something you can use straight away, and just a fairly quick way of people becoming more confident with numbers. Numbers become their friends rather than something to be scared of. Whenever I run math webinars, you always get to see my grandchildren. They're the people and the kids I still teach as much as I possibly can in schools, mainly primary schools these days. I started off as a secondary school teacher. And that's because the only way I can start to understand how children learn mathematics is by watching really carefully how children learn mathematics. Hi, Natisha. And the children that are most readily available to me are my grandchildren. And I can learn more from them because I have time to observe them learning. When I was a full-time teacher, it's really difficult to do that standing back and pausing and just watching what the students are doing. So you'll see later on that part of what I've tried to do in my Explore Math book, and part of what I try to do whenever I'm teaching, is make space to listen to the kids explaining to me how they're learning or what they're thinking, and that explains how they're learning. And then I can get a better understanding of where they're coming from, what their learning is, and that means I become a better teacher. Now, those 3 photographs are in a place called Math City in Leeds. I live in a little town called Otley, town of about 15,000 people, an old market town. It also had paper mills. An industrial town with paper mills and printing mills. Leeds is the nearest city. I think Leeds is the 5th largest city in the UK, and it has this wonderful space, which is a math museum. And it's a fascinating place, and it's a fascinating place to watch children interacting with each other and with mathematics. So you can see 3 of the activities there. One is Felix, who is now 11. This was just a couple of weeks ago. and you can get into, put your feet on that mat, and you can probably see that there's some liquid detergent around, and if you pull the ring up over yourself, you can probably see that it's forming a film. So Felix is ending up standing in a bubble. And what happens in a bubble is that the edges of the bubble start off as a cylinder, and then they move towards you standing in the middle and eventually burst. And that's because the surface tension, mathematics, increases, and so the bubble pulls towards the center, and then it eventually bursts. So there's all sorts of conversations to be had about surface tension. And next to that display, there are a whole range of grids you can use to blow different sorts of bubbles. Quinn Quinn is 3. So he's working with his 11-year-old brother and his 7-year-old brother, but you can see that they found things to do individually at this point. And he's making a rocket. But I was using the word pyramid. We were talking about pyramids. We were talking about how many. We were talking about how high. So he was doing a different sort of mathematics. And the image on the right, it's called a Soma cube. And it's a puzzle where you have to put all of these pieces together to make a cube. And because we've been going for some time, that's now the first place that the 3 of them will go to, because they've remembered how to build that cube. I've been to Math City with those 3, and I've also been, hi Laverne in Jamaica, welcome. I've also been on a school trip, and there were, I think there are about 30 students from Manchester who'd driven over from Manchester to Leeds, and came to the Maths Museum, to Math City. And what I was fascinated with those students was that they all arrived, they sat in a big circle, they were introduced by some young mathematicians. So they were 21, 23 and 24, and they were all doing PhDs in mathematics at the university in Leeds. So they were professional mathematicians, if you like, but they enjoyed working with young people. And they introduced all of the different activities that there were. And what happened at first was that they all moved around. There must be 50 or so different activities that people can do. And they moved around and they looked at all the different activities. They would start some and then stop. And it all felt a little bit chaotic. But probably within about 10 minutes, everybody was settled on an activity. Some were working on their own. Some were working in small groups. Some were working in bigger groups. And the young mathematicians had taken a group of 12 out to work on a big investigation, a big practical investigation with them. But I was fascinated that everybody had found something that engaged them. There was nobody who was saying, I'm bored, like you might get like I get occasionally in maths lessons. I don't get this. None of those sorts of conversations were happening. They were all seeing themselves as mathematicians, and they were all finding some mathematics that they could engage with, and they were all becoming more confident in their mathematics. And what I was interested in at that point was thinking, how might I replicate some of this when I'm providing resources for teachers to use in the classroom? Because what we can't do in the classroom is just have lots of activities available and the children decide which they want to do. Maybe what we can do is replicate that kind of feeling. And you know that happens sometimes with you. Morning, Marcus in the Cayman Islands. When you look around your classroom and all of the students are engaged, are talking to each other in small groups about the mathematics that you've provided with them. One of the other things that I do is edit a journal called Mathematics Teaching for the Association of Teachers of Mathematics in the UK. And one of the guiding principles says that the power to learn rests with the learner. The role of the teacher is to provide activities which unleash the power of the learner. And we know that that's true. We know that we can't make people learn things. We can make people sit quietly. We can make people do things, but we can't make people learn things. Only people can make themselves learn things. Only kids can make themselves learn things, can want to learn things. But what we can do is draw on our experience and our colleagues' experience and resources to find things that will unleash the power of the learner. And there are three images of the power of the learner having been unleashed. Yeah, the power to learn, if that's kind of on my wall in front of me just there, because I need to remind myself of that constantly. And I think what that does, and not in a way of blaming myself, is if people aren't learning, my job is to think, okay, what do I need to do differently to unleash that power? So whenever I work with schools, and again, I'm lucky enough to have worked all around the world, and they say my children don't want to do mathematics, or even a particular child won't do maths. They just keep saying, I'm stuck, I can't do it. A bit like Felix did when he was 7 in lockdown. My first question to them is, well, when are they successful? Hi, Glorine. Because there will be times in school when they are successful, when they are engaged, when their power to learn is unleashed. Might not be mathematics, it might be something else. Notice when they are engaged and try and think, what is it that's different about that to when I'm teaching them maths? And if I can move towards the things that do engage them in my math lessons, then maybe I will be able to unleash that power. So time for you to have a think about something. I want you to think of somebody that you know, and it might be somebody that you teach, it might be somebody that you work with, it might be a member of your family, it might be a friend, somebody that you say they're really good at mathematics, they're successful in mathematics. Thanks, Kieran. You preempted my next question. And then think of the skills and competencies that they have. So Kieran has already said organization. So just type in the chat and I'll start old school with a pen and paper, writing down the things that people say. So the first suggestion is organization. But I'd like you to think of somebody that you actually know to start off with, because then you can think of the skills that they've got. Thanks, Brittany. Critical thinking. Keep them coming. A stickler for data, I like that. Communication. Loves the subject. Patience, that's great. Can explain. Reasoning. Spot patterns. So I won't catch everybody's, but keep them coming in. Confident, we've talked about confidence. Perseverance, which is different to confidence, isn't it? But maybe one helps the other. Eye for detail. We had a young friend staying with us last night, and he got up early, tactical, and when I came downstairs, it was 7:20 when I came downstairs, and I said, how long is it till your taxi? And he said, it's 24 minutes. And I said, great, it'll be here at 7:44 then. And my wife, who is a drama teacher, laughed. And Amit said to me, I knew you'd like that. He said, it is 24 minutes. So it'd be silly saying 25 minutes or something, which it would be, but it's that kind of stickler for detail and maybe kind of not understanding why other people think that wouldn't be a a good thing to do. Problem solving skills. Understands the concepts. We'll talk a little bit about that in a moment. Well, I say I'll talk a little about that in a moment. Connections to real world, which we just did, didn't we? 24 minutes for the taxi, although it came early. Thanks, Kellyanne. Great problem solving skills. Inquisitive, Natisha. That's great. Multiple ways of doing things, like that 12 times table thing. Empathy. Observant, fantastic. Creative. Keep them coming, because it'll be nice to have them in the chat. I think this is saved. This presentation is saved, and we can go back through those. A good listener. What a great. Now I'm going to read through this list. Thanks, Lisa. That's really, really lovely. That's great. That's nice. That's the thing that can happen online and doesn't happen often when you're doing things live. You can kind of tell by people's eyes if people are enjoying it. But thank you for sharing that. Discovery. So that's back to Math City. As I read through this list, your list, have a think about the way that you teach math. And ask yourselves, how do I try and do this in my math lessons when I'm teaching math? How do I, and I won't be able to get through them all, how do I try and teach my learners to be observant? How do I try and teach my learners to spot patterns? How do I try and teach my learners to be good listeners? To find multiple ways of doing things rather than just the way that I've just shown them. How do I, Alice has just put curiosity, how do I teach my learners to be curious? That's exactly it, Antoinette. Okay. So I'm going to come back to the love for the subject. Antoinette's just said, be an example. And that is it in a nutshell. It's that we can be curious about mathematics. We can say, I've just found out this. We can be learners alongside our students. We can spot patterns maybe that we didn't see before by working with our learners on looking for patterns. We can be sticklers for data. We can bring things in from the newspaper, from the Gleaner, and we can question that with the students, and we can be sticklers with that data and say, is that right? And that teaches them both to be sticklers for data and to have an eye for detail. We can make connections to the real world by drawing on the students' experience. Yes, Vanessa, not being afraid to make mistakes. I often think, when I'm thinking about successful mathematicians, I think about that in the UK, there are countless cookery programs, chefs in cookery programs. And what I'm fascinated with is that quite often when they're modeling cooking something, they'll mess up. They'll burn something and they'll just throw it away and start again. And they don't say, I'm a useless chef now because I went wrong. They just say, oh, I left that on too long. And they start again. So they're not afraid to make mistakes. They know that doesn't make them a bad chef. We want our students to know that making a mistake in math doesn't mean they're not any good at math. It actually means they're learning math. Those young PhD students I was talking about will spend most of their time being wrong because they're trying to prove something. They're trying to prove something in math that nobody else has ever proved before. And they will go up all sorts of blind alleys trying to prove it. So they will go wrong, but they know that's just part of the journey. So it's having a look at that list, and I'll have a similar list at a moment, and thinking, okay, how can I do those things? How can I teach kids those skills in my math lessons? And I think a lot of that comes back down to our confidence. So if we're confident, if we learn to love math, if we can develop our own problem solving skills, maybe by doing some math for ourselves as well, then we will become a really good model for our learners. So I've kind of asked you that. I'll not ask you to go through that again, but maybe one of the things you can reflect on at the end of this session, maybe making some notes at the end of the session. I think, Lisa, you've been in these sessions before. I just recognize your name, so I think I'm sure I've had a Lisa D'Souza in these sessions before. I'm still learning maths. I don't think I didn't hate maths in school. I hated school math because it was really boring, because I could do it. I was a really weird kid at school sometimes, and I used to sit when you were doing class reading when I was 10 and 11. You would get the whatever book it was we were all reading. There were 44 in my class, and I know that because I've got the reports still. And so you knew there were going to be 44 people just reading for a couple of minutes. Great, I'm glad that you come back. So that meant that for most of the lesson, I wasn't going to be reading. And I'm lucky because I can kind of keep two things in my head at the same time. I think it might be one of the joys of being autistic. That might be one of the good things about being autistic. So I could keep the reading book open and kind of scan where people were reading. And while that was happening, I was doing math in another book that was hidden in my reading book. So that was kind of my oddness. But you can see there on that slide, Felix and Tate both engaged. Tate excited that he's managed to make a rectangle out of those four shapes. You can see there's a dice game next to it. And Felix very engaged in building 3D shapes. And I think in those sessions, they were learning a lot of the things that we've talked about. So thinking about the states, the NCTM in the States, the large-scale research on what improved results, what effective mathematics was, what the practices were in classrooms where the results were good. And this is very similar to results that I've seen from around the world. They've got 1, 2, 3, 4, 5, 6, 7, 8 points there. Establishing goals to focus learning. I did that at the beginning. I said, well, this is what we're going to do. So you kind of know what's coming up. Making sure that the activities that we're doing will promote reasoning and problem solving. Connecting mathematical representation. So that's back to the one about multiple ways of doing things, back to that 12 times table story. Posing purposeful questions. I often think that my best questions are the ones I ask and I'm not quite sure what answer will come back, because then I'll find out something interesting about the children's thinking. That's kind of a purposeful question, and it will help the children learn. It's not just testing whether they're able to follow a procedure, it's getting inside their thinking. Somebody talked about conceptual understanding, that we start with conceptual understanding and then we build procedural fluency. There are these different procedures that we can use to develop this concept. I love the next one, support productive struggle in learning mathematics. If we're not struggling in some sense, we're not learning, we're just doing. And people talked about perseverance, people talked about confidence, people talked about creativity, and all of that comes from productive struggle, I think. And I even think can explain comes from productive struggle, trying to explain what it is that we're doing. When I have a conversation with learners about why they're stuck, usually by the time they've explained what it is they can't do, they are now able to do it, because they've actually had to think really hard in order to explain what it is that they can't do, which is the last statement about eliciting and using evidence student thinking. So the 5 E's, and for those of you that have seen Explore Math, you'll notice that each page in Explore Math follows. You'll see some of the Explore Math in a minute, Felicity. And I know that the bookshop in Kingston has them, but we'll ask Alice later on, or Alice might type in how you can get hold of them. But I'm going to show you some pages in a minute. So those are the 5 sections on each page, which are what I was saying about trying to build this into a resource. So it starts off with a section which establishes goals and facilitates meaningful discourse, because it's usually a paired discussion point. Then from that paired discussion, it moves into explore, which are on the whole problem solving tasks, and where possible, different forms of representations. There's always a section where the students are explaining to each other or to the teacher what it is they're doing. And at that point, I can pose purposeful questions, and that facilitates meaningful discourse. Extend is building further on the activity, which is where they start doing this thing about building procedural fluency. And the evaluate, again, usually asks the students to describe something to the teacher as a way of finding out what it is that they're thinking. So just before I show you the pages, I want to talk a tiny bit about constructivism. And the 5 E's comes out of constructivism. So there's the 5 E's again: engage, explore, explain, extend, evaluate. Constructivism comes from Piaget. And I kind of get some confidence in drawing on my grandchildren to think about learning, because Piaget did most of his experiments, did most of his thought experiments with his kids, watching at how they learn. And his view, and it's actually my view, is that people construct their own knowledge from the experiences that they have. Now, the way that we get involved in that as teachers is by providing them experiences. So this comes back to that idea about building on students' own experience and eliciting understanding. By understanding and reflecting on activities, students are able to reconcile new knowledge with previous ideas. And I said earlier on about doing exam papers doesn't actually teach us anything, because we're just doing things. Whereas the productive struggle is where we're starting to learn things. So one way of thinking about learning is that we move through life, and on the whole, we're quite happy. Oh, thanks for pointing that out, Felicity. We're happy with the way the world is. We think we understand the way that things work. And then we engage with an activity, or we notice something, and it changes the way that we see the world. So Piaget talks about being in equilibrium, and then something happens and that throws the equilibrium, sends us into disequilibrium. And then we have to suddenly think about something. And that's the point at which we're learning, when we're now trying to make sense of something new based on the way that we thought the world was. And you will notice that in really young learners. I think it probably in 2 ways. You probably noticed with a balloon. And if you open a door, then the balloon will blow away from the door. And a child will spend ages opening and closing a door and seeing if the balloon blows away each time. Because previously balloons had stayed where they were till they hit it, and now suddenly they're moving on their own accord. And they have to work out what that is. So as teachers, what we need to try and do is find these activities that kind of shake students' understanding a little bit, and then engage them in productive struggle to get to a new equilibrium where they've learned something new. So in many ways, this means the teacher plays the role of a facilitator, guiding students as they learn new concepts. So it slightly changes our role from just telling students stuff to providing them with activities, which means they ask us stuff, and then we can engage with their questions. There you go, Saudia. Then they can engage with their questions based on what I'm talking about. Okay, so the engage section, if you like, is sharing what we currently understand about something. So where is our equilibrium? The explore moves things on a little bit and might shape that equilibrium through a problem-solving approach. Let's explore something about this. Then explain is the student saying, what I'm now noticing is, and I have that conversation. Extend builds the explore a little bit further. So let's try and make some generalizations from that, and then evaluate what have I noticed about all of those things. So I'm going to try and finish in about 6 minutes, just to give you a little bit of time to respond if you need to. And I'd like you just to have a little bit of reflection time, because I know the minute this finishes, you'll be busy onto the next thing. So here's an example of an engage activity from Explore Math. And quite simply, all I would say and all I do say to the students is sit in a pair and have a conversation. Which is bigger, a half or a quarter? And leave. I wouldn't explain any more. And these are images from the book. So there's images to kind of get the conversation started. And you'll notice that the image on the left-hand side is different representations of fractions, different ways of thinking about fractions. And I tried this one out yesterday on my wife. I always give her the presentations to have a look at. And she said, it depends. And I said, well, say a little bit more then. And she said, well, the example with the glass, it depends how big the glass is. You could have one glass half full and a bigger glass a quarter full. And the quarter full glass could have more in it than the half. So she was starting to explain that sort of thing. And then I said, is there any time when a half is always bigger than a quarter then? And she said, well, if it's the same shape, so a half of that circle at the top is always going to be bigger than a quarter of that circle. But again, watermelons are different sizes, so it depends on the size of the fruit. So suddenly it's starting to, can you see how that might shake children's previous understanding? Because they would say, well, a half's always bigger than a quarter. And then suddenly fractions mean something slightly different. So we can move on to think about things in slightly different ways. So that's a way of engaging. We're going to learn something about fractions, but let's have a think about what you already know about fractions. And I suppose part of the point of that is thinking about fractions having to have equal areas. So that half of the circle is a half because both of the halves have got equal area, and so on. An example of an explore. So, and again, these are all just taken from different pages of the Explore Math books. Wherever I can, I try and get the learners, the children, to be posing questions as well. So I just give them those images and I'll say, can you write me a story problem? So rather than me providing the story problem, the students are providing the story problem. So maybe while I'm talking, just be thinking about possible story problems that you might write about these. We talked about us posing good questions. What I like about this page is that I'm never quite sure what problems will be posed by the learners. And my only rule is that they've got to be able to solve it. Okay, and then they will share those problems with other groups. And it's interesting, that I think learners are much more likely to solve a word problem, a story problem that their friend has written than one that I've written. And I move this on a little bit, and I'll say, right, can you write me an easy problem? Can you write me a middling problem? And can you write me a hard problem? All based on the same picture. And that's interesting in terms of them. I suppose that's productive struggle again. So don't just opt for the easy answer. How many children are running to the right and how many children are running to the left? How many children are there all together? There's some very straightforward ones, but maybe think about some more complicated questions. What fraction of the children have got a sphere? What fraction are skipping? And that there may be different answers there. So that's the kind of problem posing, reasoning section. Explain. Now that you've got there, you've got a full page out of Explore Math, so you can see how every page follows the engage, explore, explain, extend, evaluate. And the explain section is just, I want the students to tell me, why are 6/10ths and 60/100ths equivalent? So they've got an image there. I think you're right, Marvelyn. Yes, so that they move between simple and complex. And maybe sometimes the simple gives them confidence to move to the complex. And what's simple for somebody might be complex for somebody else, and what's complex for somebody, they might be able to move even further. So I don't just want them to know that 6/10ths and 60/100ths are equivalent. I want them to know why and be able to extend that. And I might say, what else are they equivalent to? But that they're telling me, I'm eliciting their understanding through that question. Extend. So here's another unit. You'll see at the top of the page is the learning objective for those of you in Jamaica. Those are taken from the new standards curriculum. So it's about using the symbols less than, greater than, and not equal to in number sentences. I'm using set notation, and what the extend is starting to use a number line to show the answers. So a new way of representing the information. So they understand about the less than symbol, the greater than symbol, and the not equal symbol. Can we think of another way of showing that on a number line? Because number lines will become very useful in terms of developing thinking later on. So that's an extend type activity. And then finally, evaluate. Evaluate is always based on the previous page, and it is a way we need a way of kind of knowing if children are understanding what we're doing, what their understandings are. So for this one, I just want them to tell me what the right answers for 3 and 4 are, because I've given 5 misunderstandings about probability, and you might see that it starts off with a misunderstanding. It rained today, so it's certain not to rain tomorrow. Is that true? What's the probability of it raining tomorrow? And so I just want the students to have a conversation about that, and then still working in those pairs, saying why they're misunderstandings. So I've got a coin, I toss it 3 times and get 3 heads. So the next time, because I've already had 3 heads, it's not going to be heads again. It's more likely to be tails. Why is that? Why is that wrong? The best answer I got from that it was a young person in Jamaica when I was out there. They said, well, a coin hasn't got a memory. And isn't that a great way of thinking about probability? Coin hasn't got a memory. So it's equally likely to be heads or tails. So that was the evaluate question, if you like. So question 3, 3 red balls and 5 yellow balls in the bag. The probability I'll pull out a red ball at random is 3/5. First of all, why is that a misunderstanding? And then, so what based on that misunderstanding, what's the actual correct answer? And that's that thing about moving from being in equilibrium to being thrown a little bit, and then to go to a new equilibrium. Okay, we've got two minutes left, and I know that people are busy and probably you've got something happening at half past the hour, whatever the hour is where you are. But I always finish with this, as Alice knows. I'd be really interested if just the last thing you put in the chat is anything you think that you'll take away from this webinar. Just helps me start to understand what it is that you're thinking. That's constructivism in action, because you will all have learned something different. You all construct your own understanding from what I'm talking about. You all bring your previous understandings and hopefully move forward with what we've been talking about. Yeah, so just type anything in the chat that you think you'll take away. Thanks, Kelly. Yes, yeah, I think the 5 E's are great, Constance. That's okay. That's good. Yep. More interactive is really important, Carrie. Thank you. Yeah, problem posing, Stacey, is really. It also kind of saves us a job as well. Yeah, lots of different pictures, and getting children to draw their thinking is quite useful. It's always a good thing when people use the books at home with their own kids. I always think that, because I use it with, like I say, with the grandchildren. And it's actually quite good then to talk about to the students, isn't it, that we use this with our kids. Thanks, Marvelyn. Thanks, Charmaine. The different ways to do times tables. Yeah, having different groups working at different struggles. I'm glad that it's helping with the 5 E's, because I mean that is kind of central to the new standards curriculum, isn't it? Maybe I can come back out to Jamaica and we'll do some more work on the 5 E's. That would be lovely. Okay, Alice, did you want to finish off?
Yes, thank you so much, Tony. I hope everyone found that really useful. Really interesting and such a fantastic presentation. So thank you very much. If anyone's got any more questions for Tony after the webinar, feel free to send them to us and we can pass them on to him to get them answered. So I did mention at the beginning of the session that everyone that's attended will receive a certificate. So just check your emails. It won't be straight away, but you should receive that today.
Thanks,
and on this email, you'll also get access to slides and recordings from the webinar too. So you can share this with your colleagues if you think the webinar will be useful for them. So just make sure you look out on the email that you registered with. And if there's any other questions for Tony, please put them in the chat.
Is there Alice, the colleague in St Lucia, how would they get? Is there a Macmillan rep in St Lucia?
Yes.
That would be the way to do it.
If you go onto our website, Macmillan Education Caribbean, there's information on all our local booksellers on there. That they're the person that you'd need to contact in the country that you are. If you are in Jamaica, you can get in touch with Kingston Bookshop, and they'll give you all the information on this Explore Maths series. So yes, you need to go onto our website and all the information is there, and I'll put a link to that in the chat as well for you.
Great, thank you.
Okay.
Somebody asked if the certificate can go to the school, because there's 9 people in the school.
Yes, so the person that signed up through their email, you can download the certificate.
Okay.
And you'll be able to share that with the colleagues if they watched it as well. If there's any other questions?
I'd love to come back to Jamaica. I'm hoping we are hoping that will happen. So that would be great.
Yeah.
Thanks, Jeanette. We'll certainly let you know.
Great. Well, I think we'll finish there then. If anyone's got any other questions, you can send us an email, as I said, and we'll get back to you with the answers.
Great.
Great.
Thanks everybody.
Thank you very much, everybody.
Bye-bye.